This lesson is on slope. On a graph, slope measures the ratio between the vertical component and the horizontal component of a shift in, say, either elevation, when it's to do with steepness, or maybe money, if it's to do with some rate of change over time. Essentially, you're looking at the rise over the run as the ratio. Let's look at an example of a line in a coordinate plane and see how we can find its slope. Better yet, how can we find slope in general if we're given 2 points? Say this is point 1 and point 2. Note that slope is rise over run. And for purposes of building towards generality, I'm going to label these points so that we know that in point 1, this is our x value, so x value of point 1, and y value of point 1. That's what this means when you see it in a formula later. The x value of point 2 and the y value of point 2. So you'll notice that those points are transferred here and here to make this first point, 1, 1. So that's our x1, y1. And then here, for our other point, that's x2, y2, which was 2 and 4 as their values. So recall that slope is rise over run. So how do we find the rise and the run between these 2 points? Well, you can see that you go up 3 and over 1. But how do you determine that based on just these points without the graph? Well, let's base it on the graph. In the graph, you see that it's going up 3, but that's because it's changing from a value of 1 to a value of 4. So the rise actually is the change in our y values because that changes the height. So if we go 4 minus 1, which is actually our y2 minus y1, we get our rise of 3. How do we find our run? Well, we can similarly look at our x values to look at how far it's traveled left and right. So it's gone right by a unit of 1, and that's because it's gone from 1 to 2. So you would go 2 minus 1, giving you 1. And therefore, the ratio simplifies to 3, and so the slope is 3. Up 3 over 1. So in general, to find the slope between 2 points, and if the 2 points are given with these indices, you're looking at the change in the y as the rise and the change in the x as the run. This is for slope. And the difference quotient is what we were just looking at. And that's actually taking the y2 minus the y1 as the rise and the x2 minus the x1 as the run. Note that you could subtract the other way as long as you're going in the same direction, because you want to find the difference of your y's and the differences of your x's in the same direction so that they simplify to the slope. So let's take a look at these examples and see if we can read their slopes. So the first example, in reading slopes, we need to find some stable points. So here's a stable point that's on a nice marking, and here's another one. So those 2 points we can use to find our slope. So how much is it going up and how much is it going over by? And visually we can just look at it in this way, whereas if we were doing it mathematically, or numerically I should say, you'd look at the coordinates of this point, which is -5, -3, and the coordinates of this point, 3, 3, and you could apply that formula. We'll do more of the application of the formula later, but in this case you can actually count because it's nice and easy. So what's the rise here? 1, 2, 3, 4, 5, 6. So it's rise 6, run 1, 2, 3, 4, 5, 6, 7, 8. and that simplifies to 3/4. So the slope there is 3/4. Great. Okay, I also draw attention to the fact that this is positive 3/4. Let's look at the next one. Here's a nice point. Oh, here's another nice point. So in this case, we've got -1, 0, and -3, 1. And you could subtract, you could go 1 minus 0, that's your rise, it's 1, -3 minus -1, which is actually -2. So what does this mean? Well, this means that you could rise 1 and go left 2, or you can go and write this as down 1, right 2. Notice this rise over run formula here tells you to subtract. But you can also notice that in reading a slope, if the rise is positive, that's up. If the rise is negative, that's down. If the run is positive, that's right. If the run is negative, that's left. So you can see we can read this as up 1, left 2, or down 1, right 2. Either way, it's a negative slope, and you can answer either way, that's fine. Okay, let's take a look at this one. Well, there's a lot of nice points here. Let's choose these two. So what happens here? How much is it going up and how much is it going over? 1, 2, -2, 2. Well, our rise will be 2 minus 2, which is 0. There's no height. And our run will be 1 minus -2, which is 3 in this case. But I could have chosen any other number, and this could have been any number. Either way, it simplifies to 0. So the slope is 0. Notice that it's a flat line. If you were a little person walking on this line, you'd be really happy because there's no grade. If you're a little person walking down this line, you'd be kind of happy because you're going downhill, but maybe your knees are hurting. And if you're this guy going on a positive slope, you'll notice you have a bit of an incline to work at. What about this? Can you be a person and can you walk up this line? Well, what's the slope here? So the slope here, let's just pick 2 points here and do the math and see what it ends up with. So what's the rise in this case? Well, the rise here is 2 over run of 0. You can do that with points yourself. But no matter what I choose, I get some number over 0. Can I divide by 0? Check on your calculator. No, you can't. It's actually an undefined slope. So this person can't actually walk up this vertical slope. It's an undefined slope. Maybe they can put some climbing gear on though. So just to see the points here, this point was -1, 0, and this point was -1, 2, for example. So let's notice a few things here. What happens if your x1 is the same as your x2? Meaning your x variables are the same. Well, you know that's an undefined slope, and you also know that it's a vertical line. What if your y's are equal? Well, that was this case where the y values were equal. So it's a 0 slope and it's horizontal. What happens if the slope is positive? Well, the slope is positive, that means the line is increasing from left to right. And if the slope is negative, that means it's decreasing from left to right. These are really good intuitions to build because eventually it helps you tell if you're doing the right thing. Another thing to notice is the difference between the slopes when lines are parallel or if they're perpendicular. If they're parallel, what do you think? Well, here the rise is 3, run is 2, so that's a slope of 3 over 2. Here, the rise is 3, the run is 2, that's also a slope of 3 over 2. You'll notice they have the same slope if they are parallel. What if they're perpendicular? Well, this one is 3 over 2. But you'll notice to make a 90-degree angle, you can imagine rotating this L shape by 90 degrees and it would fall just like this. So you know that the lines are at a 90-degree angle also. But what happens to the slope then? Well, that then is a rise of 2, actually negative 2 because it's a fall of 2, and a run of 3. So the difference between those ones is that they are reciprocals and they're negative, and this will always happen for perpendicular lines. Let's try some examples of calculating slope. So we can calculate slopes for the following lines, and we want to know if it's increasing, decreasing, horizontal or vertical, and if they're parallel or perpendicular. So let's find the slope here. So we have, for the first example, I'll just label this. So you know that you're going 5 minus negative 3 as your y values, and negative 2 minus 3, which is 5 plus 3, which is 8 over negative 5. And that doesn't simplify, so that's the slope. What kind of line is it? Well, it's a decreasing line because it's a negative slope. You can put the negative up top as per convention, but that's fine as well. Let's try this one. So the slope is going to be 3 minus 8 and negative 6 minus 2. So that gives us negative 5 over negative 8. And that simplifies to 5/8. So that's increasing. Now what do you notice between the two? They're reciprocals and the signs are changed. Therefore, because, and this is a nice check, you can check if they multiply and give you -1, then it's just a check that they're perpendicular. So these two lines are perpendicular. Let's try another example. So again, going 1 minus, the slope is 1 minus negative 5, and negative 2 minus negative 2. We're taking our y minus our y and our x minus our x. Notice m, you might wonder why it's m, but m is for slope because René Descartes was French, and in French, to climb is monter. Let's continue here. We got 6 over negative 2 plus 2, which is 0. Ooh, what happens there? Well, we actually could have noticed that our x values were the same, meaning it's a vertical line. This is an undefined slope. So you answer undefined for slope, and you know that it's a vertical line. Let's try the next one. This one has the same y value. So you'll notice you get 0 over negative 5, which is 0. So it's a 0 slope, which means it's horizontal, flat. Great. What do we know about if they're parallel, perpendicular, or neither? Well, if one's vertical and one's horizontal, then they are obviously perpendicular. But in this case, you can't use the negative reciprocal theory, and this is the only case because you've got zeros here, so you can multiply 0 by an undefined number, but that doesn't really tell you anything. But you can visually imagine if you have a vertical line and a horizontal line, they will naturally be perpendicular. Finally, I wanted to give you an example where you have some fractions to deal with. So same thing, you go 2 minus 9/7 over negative 2/17 minus negative 7/17. It's nice that these have a common denominator, but these don't. So you can say that's 2 over 1. And we need a common denominator, so multiply by 7. That leaves you with 14/7 minus 9/7 all over negative 2/17. And I'm going to make the 2 minuses a plus, 7/17. So that gives you 5 over 7 over 5 over 17. Remember, when you're dividing two fractions, that's the same as multiplying by the reciprocal. And so when you multiply these across, you can see that the 5 will be divided by the 5. So you're left with 17/7 as your slope. No simplification there. Let's try this last one here. So take away your y's, you have negative 1/4 minus negative 7/8 over negative 2/5 minus 1/2. So we need a common denominator here, so we need times 2 times 2, and here we'll make these a 10, so times 2 times 2 and times 5 times 5. So you've got negative 2/8. Two negatives make a positive 7/8 over negative 4/10 minus 5/10, giving you 5/8 over negative 9/10, and multiply by the reciprocal and simplify. So you've got 8 and 10 simplify to be 4 and 5. You're left with 25 over negative 36. And those don't simplify. So this one was positive. This first one here was positive, and so that's an increasing line. This one was negative, so that's a decreasing line. However, they are definitely not the same and not reciprocals of each other. So you would say neither, because they aren't parallel or perpendicular. Finally, you should notice that sometimes you're asked about collinear points. Those are points on the same line. So how do you check if points are on the same line? Well, notice if 3 points are on the same line, they have to have the same slope. Otherwise, they won't be on the same line and they won't have the same slope. So I urge you to find the slopes and determine whether these points are collinear or not.